you very much. Hello, everyone. Thank you for having me here. So we are going to, talk about Red Hat and Microsoft and Linux and testing. I came from the open source world, and I've been doing software testing at Red Hat for a very, very long time, as you can see. And I love to speak at conferences. I don't have any other pictures except somewhere I've been at a conference. I am also the project lead of KiwiTCMS, which is an open source test case management system. And it's an interesting project with an interesting history, so please check it out, give me feedbacks, report bugs if you need something like that. We are happy to fix bugs for you. And with that said, I'm done with the shameless self-promotion, and let's talk about Pairwise testing. Anyone familiar with what Pairwise is? Okay, 1, 2, 3. Couple guys. Okay, cool. For the rest who are not familiar, I have an example to demonstrate. Imagine that our job is to test this car, and because we are diligent testers and we look carefully to what's given to us, we see that we've got a few options for batteries and a few options for wheels, and also we have performance mode and dual engine, single engine, and stuff like that. So we have options which these are input parameters which may affect the performance of the car, so therefore we have to test them. And here is a list to make things easier to comprehend. And just for the sake of the example, I have added some more options so we can have more combinations in the example afterwards. And these ones I've just make them independent of one another to make things simple, for example. If you want to do exhaustive testing of all these parameters and their possible values, we have 32 different combinations between the two, which means 32 different test environments that we need to work with. Or in reality, if we're testing the car, that means 32 different cars for test. So that's quite a lot. Pairwise is all about reducing that number. So Pairwise says we should not test all possible combinations between all parameters that we have. On a website, they claim that in complex software systems, you don't need to be able to control all the input parameters at once to trigger some defects. You need to be able to control at most 2 of them to trigger pretty much all of the defects. Not all of them, but a good amount of them. So if you can trigger defects by controlling only 2 parameters, that means you can design your tests to take into account combinations of 2 and not combinations between more parameters. So Pairwise is it's also called all pairs of 2 testing. And in this matrix, in the example, if you look at it, it contains all pairs. So 60 kilowatt battery with single engine, and then 60 kilowatt battery with dual engine, and then again 60 kV with 21-inch wheels and with 19-inch wheels, and so on. So it contains all possible pairs of 2, but doesn't contain all possible combinations. And the maximum size of this kind of matrices is determined by the 2 parameters with the largest set of possible values. So in this case, we have battery with 4 values and engine with 2 values. So yes?
Well, I said it's all combinations of 2. What about single, no, and for example, there's no line
Which one?
Single engine and no performance mode.
Okay, single, and okay, yeah, bad example. So that should be, so these should be here. Yeah, because I've created this by hand to be beautiful. Yeah, good catch, thank you. Thank you. So yeah, that's the 8. In this example, 8 is the largest possible value of this matrix. So you take the 2 parameters with the most values and multiply them, that's the largest size. And obviously 8 is much smaller than 32. There is a community website called Pairwise.org. Microsoft is sponsoring it, and they seem to be pretty much the only one entity that is promoting this kind of testing, at least to my knowledge. On this website, there is a list of a lot of research papers. There's also a list of many different tooling for different programming languages available from the website. There is also a Pairwise tool from Microsoft available on their GitHub account. And they claim that pairwise testing is effective at finding defects, and it's an effective test strategy And using these tools that are available and knowing how Pairwise works, you can actually use it to generate your test cases with particular parameters automatically. So you have some tool that tells you what to do when you perform testing. And this is what I did. I made an experiment which involves installation testing of Enterprise Linux, version 6.9 in particular, where I applied these techniques to the entire testing campaign of the product and across all product variants to see what will happen. So we're going to talk about the experiment. Installation testing very quickly. This is what my team does and what I'm going to talk about. We have this program called Anaconda. This is the installation program for Fedora, Enterprise Linux, CentOS, these types of distributions. And our job is to test that piece of software to make sure Linux can be installed on your computer. And when you click the finish button, the restart button in the installation screen, you can actually reboot into a possibly working system. At least you can be able to log into a command line and fix it from there. And it's mostly written in Python with the graphical user interface. It has also text mode user interface, command line, fully automated interface. We have integrations with different tooling from Linux. So, for example, here it says file system type, and it's drop down. You have all possible file system types that are supported in the Linux distribution. And to be able to perform partitioning with these file system types, the installation program integrates with the command line tools for that particular file system. So we have one screen, but it does behind the scenes, it does different things. We also have, for example, networking to download from the network inside of the installation program, and that's a network manager. We don't manage networking by ourselves. We just integrate with network manager. And all these integrations, they can be a source of problems. And this is usually how our test cases are designed. We try to design around these integrations and what could possibly go wrong. From the point of view of testing, we have 9 different product variants. So we have stuff like client and server and workstation. And we have different CPU architectures, different hardware that these variants run on. So we have Intel 32 and 64-bit. And we also have IBM Power and IBM Mainframe that we support on the server variant. And in Fedora or new versions, we have other hardware platforms like ARM64, for example. So this number can grow. It can become very large. The traditional way of how the team is handling that is for each product variant, which is some content set, and on a CPU architecture, we have one person that is dedicated to only that variant, and they are responsible for testing everything on that variant. We call them variant owners or architecture owners. The interesting thing about all these variants is actually that they are mostly the same thing. The software is the same when the software is put into the installation media. Our build servers, they have no idea for what kind of variant they are building. And the software itself very rarely does any checks to see on what platform it's running. Pretty much all the times we only check what is the underlying CPU architecture if we need to do something which is specific to that architecture. So for the majority of cases, all of these variants work pretty much in the same way. And when I told you I do testing for a long time, I've been testing installation for the last 11 years. And I very rarely have seen bugs about something that works on one variant and the same thing doesn't work on another variant. So that's why I think it's mostly safe to consider these product variants to be independent and to be the same thing. And you'll see why later. The test suite that we primarily use for installation testing is split into 3 groups, so-called Tier 1, 2, and 3. Tier 1 is a very, very small test suite. It's fully automated. It runs against every single build, against every single product variant, and it's not subject to my experiment. We don't want to touch it. Tier 2 and 3 is the subject of the experiment. It's a much, much larger test suite. The number of test cases in the Tier 2 and 3 group is almost 20 times as much compared to Tier 1. Traditionally, we try to execute Tier 2 and 3 at least once per week. We try to complete all the testing. Our testing campaign is usually several months long, and during that time, we average around 6,000 test case executions, which means 6,000 times reboot into installation media, take your time, about 20 to 30 minutes to complete the installation, and then reboot into the system to see if it's working as expected. So that takes quite a lot of time. Obviously that doesn't scale much, and let's see what we can do about it. So I've studied my test suite and created a very, very simple experiment. The first thing is that we actually do some test cases which are platform dependent. Not many of them, mostly on IBM Power and IBM mainframe platforms. So there isn't much we can do about them. It's not like we cannot execute these cases. We have to execute them. So we just take them and transfer them to my experiment test plan and go on from there. And then we have a larger group of tests which have parameters. So stuff like we have a test case called storage/iSCSI, and that means perform installation, attach a disk over the network, and place the root file system on that disk. And for that test case, we have authentication type, and we're interested in only these three. And we also have a networking subsystem that manages the iSCSI connections on Linux. And on RHEL version 6, we have two networking subsystems which need to be able to work pretty much in the same way. So for testing, that means 6 combinations for only one test case. Now I said the pairwise is something to do with parameters. And if we try to apply pairwise here, we don't get any difference because we have only 2 parameters. And looking at the existing test suite, almost all the tests have only 2 parameters. Very rarely we have 3, 4, or 5 parameters in a test case that we want to test. But across all variants, I have to execute these 6 9 times, so it equals 54. And I can consider the variant to be a parameter to testing. And this is what I did. I've applied pairwise across all parameters, including the product variant S parameter. And now that we have 3 parameters, we can do the calculation. We see that we get 50% reduction immediately, which is yay, cool. And the last group of tests that we have in our test suite are such that they do not have any visible parameters that we care about. And for example, we have this called partitioning/swap on LVM, which means install Linux, do the partitioning, don't care what you do, as long as you place the swap partition on LVM, on logical volume, and make sure that it's working. And the only thing I can do about it, instead of executing it 9 different times for every single variant, I can randomize and say I want to execute only 1 time, and for every different build, I want to randomize on what product variant I'm executing that cases from this group. So this is the third part of my experiment. Very simple algorithm, and I was very quick actually to create my experiment, but I needed some acceptance criteria, and I know I should have done this beforehand, but I actually defined them after I knew how to execute the experiment. First, I obviously want to have less test case executions in total, so anything under 6,000 will be fine, and you can actually calculate on paper how much savings you're going to get even before starting testing. The second is more hard to measure. I don't want to be missing existing bugs, so I want to test less, but at the same time, I don't want to say to my product manager, yay, everything is green, because I didn't test, so there were some bugs, but I have no idea what these bugs are. And for that reason, I compared the bugs that I found during my experiment with the bugs that the rest of the team has found. And the last one is even more trickier to measure. Don't increase product risk. And for the sake of the experiment, we measure product risk as the number of bugs which are reported as critical and that I was not able to find for some reason. And I want to know why I was not able to do this, because I want to make Pairwise the main testing strategy. The results, before we continue, if anyone isn't clear about this, I made my experiment in parallel with the rest of the team. So anything that I was doing had no impact on the release schedule of the product and on the work of the rest of the team. So everybody else was working like they were used to before that, and I was doing everything alone, just as an experiment in parallel. This is pretty much my most.
Do you want questions during your presentation or at the end?
If you're quick, we can do it now.
You didn't mention any reference to historical bugs as hints for axes or variants, as parameters, or indications of a multi-parameter bug that you might have missed. Did you look at historical bugs?
No, pretty much no. So this is my most impressive metric. I was able to achieve 65% less test case execution. So I didn't execute 6,000. I executed about 2,000, which is cool. I was able to achieve 76% execution completion rate. So that means from all these 2,000, I was able to complete 76% of them. And the historical average for the Rev 6 release of the team is 85%. So I remind you, I was working alone. If we work as a team using Pairwise, I'm sure we can beat 85%. We can probably do even 100% if you want to. So that means how much work I was actually able to complete. Now about bugs, here are some findings that I didn't expect, and they were actually very interesting for me. 30% of all the bugs that were reported against installation for that release and for that testing campaign came out of the Tier 1 test suite. So they were actually discovered very early in the release cycle. For me, that means Tier 1 test suite is doing a very good job. We can probably tweak it a little bit and increase that number, but maybe we're going to come to a threshold very soon, and that's a completely different experiment on its own. But yeah, we don't want to touch the way we do Tier 1. That's our first line of defense, so it's proven to be good. The other 30% of the bugs were actually found by Pairwise. So what that means is it's either I found some bug and I reported it as new bug, or either somebody else was able to report it and I was able to reproduce. Pairwise, the test cases in the Pairwise plan, they are a subset of the test cases of the full test plan. So this is cool. Now we do 65% less work and still find 1/3 of what we were able to achieve. So that's very good. That for me looks like the claim that Pairwise is indeed effective at finding defects is actually true. And I was actually expecting that not to be true. This is very surprising for me. I didn't expect this. 30% of the bugs were found by exploratory testing. And I went through every single one of them to read what the guy did and how they found the bug. And for most of the time, it's not like somebody was sitting in front of the computer and trying to do anything particularly crazy. They were actually following another test case with steps to reproduce, but either they did not follow the steps in exactly the same way, or the setup environment was a little bit different. So maybe if you have a test case which says you need to have a RAID set up on the system, the test case itself doesn't say if it's going to be RAID 1, RAID 0, RAID 5, what type of file system should be there, these kinds of things. And we come across these edge cases, and I'm not sure if it's a good thing or a bad thing. One thing is sure, it means we have edge cases that we have not described in enough details. So we hit them and we want to have more details. We want to have more automation to be sure that these things don't regress in the future. On the other hand, we like to give test engineers a lot of freedom and 10 people on the team, even though we have automation and we have tooling, they use them in different ways, and we have these kind of things. Stuff that I was not able to find. 4 critical bugs, 3 of which are regressions. I have given the bug numbers, but unfortunately we have a policy: anything that is found before the product is released to the general public is reported as private. So you are not going to, these are in bug 0, but you don't have access to them, unfortunately. So you have to trust me on that. The first one is after installation with IBFT, the default route is missing. So IBFT is like a network attached disk starting directly from firmware. So it's like booting on a network disk directly without having local disk on the system. If the default route is missing, pretty much everything's messed up, and you don't have networking working. And that turned out to be firmware dependent, which is very good for me, because that doesn't affect the results of my experiment. So firmware, hardware dependent problems, they can happen regardless of what type of testing you do. So it just happened that that particular system was faulty, and developers and everybody else were not able to reproduce on other hardware. So yay for me, cool. The next one is more serious. Anaconda, the installation program, failed to get kickstart file from NFS on mainframe. So kickstart files are text files with configuration how to drive the installation automatically. We have functionality in the installation program to bring up networking very early, right after boot, and try to download these from the network if they are specified, so that we can continue unattended from that point on. And this is interesting bug because it's a regression fixed by a change for another bug. It's also corner case only on mainframe, and it happens only on IPv6. It doesn't happen on IPv4. The reason that I was not able to find this type of bug with pairwise testing is that the test case test with kickstart from NFS, we have this thing in the test plan. But this is one of these test cases that I consider independent, and I try to randomize. And when I looked at the results, I've always randomized this on the Intel variants, on the Intel architecture, and I'm nowhere expert on mainframe, so I pretty much have no idea how to work with mainframe. And my randomization tool was very stupid. It didn't look at previous executions to say, oh, you've tested this on Intel, so let's try and test on some other platforms, so to make sure that we distribute evenly as possible. Next one is again networking related iSCSI. In the installation program, when you want to attach a network disk, there's a small checkbox says bind to that particular network interface if you have more of them. I tried testing this very early in the testing campaign, and I messed something up with my setup environment. I decided to do this manually. And I messed up, and I said to myself, okay, I'm going to skip this because we have several more builds to test with. So I'm going to skip this because I don't have time. I'm doing an experiment. I'm kind of like on the clock. Then comes the next build, and for some reason, that particular test case was on the compute node variant, which is a very minimized Linux version with less software available, intended for high-performance computing. As surprise, the compute node variant doesn't have the iSCSI clients iTools available into the installation program, so the installation program just hides the screen. It doesn't allow you to access this functionality. And I did not test again. So I skipped this test case several times, and all the while there was a problem. So when I learned about the problem, I went back to the first time. I skipped my test and tried to reproduce, and this time I was able to actually reproduce correctly. So that means I need to be more diligent as a person when I do my job. And the other one is, again, a regression, some errors in upgrade log when we do upgrade. We don't want to have these kinds of errors because customers call us. If something is really horribly broken, then we should have caught this before the release. And if it's not that bad, we try to silence these errors as much as possible. Because there's pretty much there isn't anything we can do about them. So first thing, I tested this and I tested it very, very early in some of the first builds. And then we have this kind of policy going around. If you have a lot of work and you've tested something, continue with the stuff that is left idle, and only then when you're done, go back and retest what you've done previously. And this is what happened in that case. I tested it early, it was working, I said, okay, this passes, I moved on to other testing. Then there was a new build, there was a regression that broke, and I did not test for several releases, for several builds. And, you know, problem, again, I skipped testing. So a few lessons that I learned from this experiment, and hopefully they are something that you can apply to your job or inspire you to do something else. Yeah, I have a lot of free resource now on the team. If we do 65% less actual testing, then that means I can have only 3 or 4 persons on the team working on the product day to day, and I can have the rest 6 or 7 people from the team doing automation all the time, working on infrastructure all the time, and this is huge. If I have 6 people doing automation all the time, it's like having a second team. This is great. The other thing that I learned for myself is we need to do test review more regularly as a team, and I'm not talking about going to the bug tracker and see, oh, we have these new bugs or we have some regressions. Let's review test cases which are related to that area and improve it. I'm talking about sitting down and reading through the entire test plan and through all the test cases as a team together, maybe once a month or once every 3 months, something like that, so that we share knowledge, we exchange ideas. And by doing this, I had to do this because I needed to know what parameters are in there in these test cases so I can create my experiment. And I found we have test cases with hidden parameters, so variables that affect the way we do testing, which is not explicitly described. So that's hidden knowledge within the team. I also found duplicate test cases, some purely duplicate, some which overlap and test pretty much similar things. So all of these are sources of optimizations which we can apply to the team. And I did not change this because I didn't want to affect my results anymore. I just, if I saw something which is bad, I just left it as it is and simply executed it, because the rest of the team, they didn't know that was, like that. Yeah, so perform test review, hopefully regularly as a team. This is cool. And I've observed some patterns in the way I was performing my experiment and the way we do testing inside the team, which is particular to our environment, like how we set up systems, how we trash these systems afterwards. This is also source of other optimization, but my advice for you is actually either take a lot of notes or have somebody else to watch what you do and they take notes, and then change. Somebody else does the work and you take notes, and then you compare notes, try to find patterns, and this actually works really well. If you have a lot of notes, then you can read through all of them and see what you've done, and see things that you do repeatedly. Maybe they are good, maybe not. And all of this in the context of pairwise is that all of these combinations, they can be considered parameter. If I execute test cases in batches, what exactly test cases are in the batch, and just you can do pairwise again and again and again. And I've never done this. It's just an idea. It's probably going to work. I don't know. There is risk with this testing strategy, because we do not do all the tests all the time for every single build. We are not going to execute them anymore, but as a team, I've presented this to my team. We have ongoing talks about this, and we think it's a viable strategy for us to do testing on the whole product. We think we can minimize the risk, we can mitigate it somehow. The most important thing is the human factor, especially when you skip testing. Everybody needs to know what's happening underneath. So that's the most important thing for me. And that said, I'm done talking, and now it's time for you to ask me questions. Okay, first question there. Yeah, you go ahead.
The question is, based on math which you provided about percents and 4 bucks at the left, right, can conclude that 10% is 4 bucks, right?
No.
So you had 40 bucks. Okay, can you tell how much bucks did you find?
No, I cannot tell you that.
Okay.
So the question was, can I tell you how many bugs we had in the release? I cannot tell you this. You can look at the errata records that Red Hat provides on their website when we update, and most of the bugs are listed there publicly, but not all of them. Yep, go ahead.
Do you have examples from maybe from other projects or even from the history, the bugs which could be not found with pairwise, which are dependent on 3 parameters or 4 or more parameters at the same time?
Yeah, okay, so the question is if I have examples from history that about bugs which cannot be found by pairwise with 3 or more 4 parameters, pretty much like your question. Or no?
I think he gave an example. Wasn't your example 1400844?
Tell me the title. 1-4?
But I think
Which one?
top one. Top one
The-
on this
the
slide.
first one.
Isn't that one an exact example of the question you were asking?
No, that was different one because the parameter was not a part of pairwise. It was...
Yeah, that.
It says that it was missed.
No, it was before pairwise.
Yeah, maybe you can answer that for me, but yeah, it's this is not an example of what he is asking about, and you know, I do have access to historical data. We keep track of everything that we've done in the last 15 years with respect to installation testing. You know, but it's not very easy to query. You have to go through and read everything manually. Yeah, I don't have answer for you right now. You know, we've never looked at this data before. But just based on general feeling that, you know, just from experience working with the same products for so much time, you know, I believe, you know, the things that we are not going to find, the things that we are going to miss are not that many. Okay, go ahead.
There are certainly some parameters which are obviously dependent on each other, like the choice of file system, the choice of partitioning, for example. But if you can identify a set of parameters which are independent from each other, for example, how you bring up the network and partitioning, is there some proof that by having independent parameters, Pairwise testing will not reduce the coverage? Like it's intuitively true, but do you know if this can be proved?
Okay, so the question is there any proof that if we have independent test parameters and do pairwise, that's going to reduce test coverage? Not going to reduce, sorry. Well, I don't know if there's some research done on that topic. Maybe these white papers that I mentioned on the Microsoft website. You know, you have to read all of them. I admit I'm more like a practical guy. I never went to read all of them. You know, just look at the technique. And actually, I was told about this technique by a former Microsoft engineer at another conference. But yeah, I don't think it's going to reduce coverage because still you have a lot of mixture of test case executions, and you know that adds up to. Also, with respect to coverage, with previously in different experiments, we've compared data from doing manual and automated testing on different platforms, and coverage for the installation program in terms of percent of code covered is pretty much the same all the time.
And that, I guess, would be your
Yeah, even if you do a default install without touching anything, you know, it pretty much touches everything in the source code. So yeah, we have something like 80% coverage, which, you know, it's really meaningful, not really meaningful metric, but okay. Yeah, you go first. This one. This one.
It's about that you don't cover in the pairwise because it was not defined in the parameters, right?
Yes. So these are pretty much all.
Could you restate the question?
Yeah, sorry. The question is if that bug, the first one, is not covered by Pairwise because it doesn't have parameters, or
Yeah, because it's.
yeah. Well,
Are you thinking now on changing parameters?
Well, that test case as defined, it doesn't have any parameters. So we want to make sure that this thing called binding to network interface actually works, because when you select this option, this creates configuration files which need to be corrected, need to be present on the file system after reboot. And pretty much all of the bugs that I was not able to find are of the group which don't have parameters explicitly listed. And that was my problem. Because they were randomized in such a way, or I didn't test them very well enough, so I missed them. Yes, go ahead, please.
Experience with TripleWise testing.
The question is if I have experience with TripleWise testing. No, I don't have. I've heard about this, but I don't have experience.
So yes, the theoretical, the literature does describe testing in triples or even larger, but the research hints that pairs are enough.
Yeah,
that was the rationale. And the Microsoft research papers on it are fascinating.
Yeah, so the classical example on, I'm not sure, one of the Microsoft articles that I've read about is if you open Word, this is where they came up with the idea first. In one of the settings dialogues, it has like 5 or 6 checkboxes, and you can check any one of them in any combination. So that's a lot of combinations. And there's like thousands of checkboxes in Word for settings and stuff like that. And if you want to test everything, that's just huge. So they decided, okay, looked at something. There isn't a lot of information how they came to the conclusion that 2 is enough. They just say, okay, 2 is enough. I said, let's do this, and it's proven in practice that it works. How much time we've got? Oh, 10 minutes left, okay.
Do you have any tool or you are using a script?
Okay, the question was if I have any tool or if I was using a script. So I mentioned there are many tools for different languages. In my particular case, I did not use the official Microsoft tool, because that one is you need to compile it, and I'm a Python person, don't like to compile stuff, and you feed it a text file with the parameters, and it just outputs the matrix of the combinations. I used the Ruby Pairwise gem, which can be used also in Ruby scripts, and it also integrates well with the Ruby testing tooling. And I used that I fed it with lists of my test cases, parameters for every one of them, just describe this in declarative order. Just said, I have this and this and this. Now let Ruby do the work and output the list of cases and the list of parameters I need to be executing for every single build. And actually, I've noticed the Ruby tool doesn't apply the pairwise algorithm very correctly. Sometimes it produces duplicate entries. But that isn't that big of a problem. It's probably like 1 or 2% of the times.
Sorry to add, there is online tools for just to quickly to try them out.
Okay, so he says there are online tools to help you with this. But yeah, there are tools for every popular programming language out there. Okay, a question in the back? So the question is about how quickly I find a bug. Can you repeat? I kind of don't understand what you mean.
So your main metrics were whether or not you found a particular bug.
Okay.
But did it also affect, if say, because you're only able to do so many tests per time, did you find bugs like that were missed, say, the first time you did it, but then you had a different set of combinations the next time, so you found them late?
Okay, so the question is if there were bugs or that were not found the first time maybe, but then I tested with different combination of parameters in test cases and found them on the second time. Well, I don't have that information, because if I found something, let's say in build number 2, then I have to go back to build number 1 and try to reproduce that thing. And I don't know if it's been introduced in build 2 or if it was there before that. It is possible to do, but that's a lot more work to get the data and to validate the statement. Did I answer or no? Okay.
Did you find that by testing less often, like you also miss more race conditions? Like sometimes there's a bug which happens, like depends on timing and stuff, and like it makes things like it seems like it's more easy to miss these. Did you have that experience?
Okay, so the question is about race conditions, bugs that depend on timing, and if I had experience with this in the context of Pairwise. First of all, during installation, we don't have these kinds of problems pretty much none of the time. At one point in time, the installation I think was multi-threaded, but currently I think it's mostly single-threaded because it was very hard to debug these things in the installation environment. You know, you have to burn ISO media, reboot systems and stuff like that. It takes a lot of time simply to get to a point where you can debug something and figure out what's going on, and it may not be reproducible. That said, you know, if you do desktop testing or, you know, something else which can be easily tested and reproduced, then I guess you know, you can have problems with race conditions. But again, you know, the race conditions, they happen kind of randomly, so you don't have any idea whether or not Pairwise affected the you know, the happening of the race condition.
Yeah, I mean, it affects it by the sheer, like because you just run them less often, so you have a chance.
I tend to disagree with that because, you know, if I run my tests all the time, but I run them on the same system with the same load and, you know, kind of in a predictable environment, the race condition may never happen.
So had you evaluated associating code changes to your test selection and having that be some governor for the pair selection?
We do this kind. So the question is, have I evaluated associated code changes to govern the parameter selection in testing? We do this when we design test cases, like for new functionality, for example. We have bugs, and we try to evaluate this and need to create new test cases. We do that kind of analysis, but that's not subject to the experiment. I just took whatever was existing at that point in time, and I knew the team was going to use the same set of test cases which have been already created before the release, so I just used that. But on the other hand, yes, now that we know how Pairwise works, we can be thinking more in terms of parameters to testing, because honestly until now we haven't thought a lot in terms of parameters. So if the parameters were obvious, yes, we put them into testing, and if they weren't that obvious, you have to, you know, kind of go to the source code, see what's happening, or have some customer tell you that yes, this is a particular problem in one particular environment, so we can, you know, add parameters to that. And also you have to realize the existing test suite, that's a product of many years of you know, development of the installation and upgrade of the test suite. You know, it's not something we came up just before the release. So it's based on a lot of historical data. Okay, if you don't have more questions, thank you for being here.